All right, let's get rolling. Hi, everyone. Welcome to today's webinar on Earthwork Assessment Fundamentals and Challenges. We're going to be discussing a modern approach to terrain analysis for ground fixed tilt, standard, and terrain following trackers. Thanks so much for joining. We really appreciate you being here and hope this is an enlightening discussion. Please don't hesitate to submit questions either during or after the webinar, and we'll do our best to answer them within the next few days. So let's get started. I'm Jason Spokes. I'm Senior Director of Project Engineering at Terabase Energy. I've been in the electric power industry for over 20 years now, and in the large-scale solar industry for over 10. My background is not in civil engineering, which is why I am accompanied by Dylan Mora. He's a senior civil engineer at Terabase, bringing with him over 15 years of experience in civil site design. His interest and experience on how solar farms fit into the natural world lends itself very well to our topic today. And Dylan has been instrumental in the development and validation of our Earthwork software that I'll be previewing later in the webinar. Before we get into Earthwork, I do want to give a brief overview of Terabase for those who may not be fully familiar with this. We're a Berkeley, California-based startup founded in 2019. We're building digital and physical solutions to help accelerate the deployment of solar, and that's what you see on the screen here. Starting on the left, we have our software and services for the development pre-construction phases of the project. Central to this is PlantPredict, which is our solar energy modeling engine. We've been expanding PlantPredict into a full suite of professional design tools, including layout automation, material estimation, economic modeling, and now grading analysis, which is the focal point of today's webinar. We also have construction products and services in the middle here, including construction management and monitoring software. For the physical world, we've built a construction automation solution, which we call TerraFab. We basically bring a mobile factory to your project site, complete with an assembly line and rovers to automate the module to torque tube to pile assembly. We've completed our first beta deployment of TerraFab last year, and the first full deployment is underway as we speak. Finally, over to the right, we have our plant controls team that provides a full set of SCADA and power plant control services, including hybrid control systems. For today's agenda, we want to start with a question: Earthwork, why should I care? And then I'm going to hand it over to Dylan. He's going to take us through some important civil engineering fundamentals. He'll also discuss some key challenges to performing array grading using traditional methods. We'll present Terabase's modern approach to performing earthwork analysis and grading design. We'll give you a preview of our soon-to-be-released Terrain Pro application, and then we'll end with a recap, some takeaways, and live Q&A. Just a note that we will be holding all questions until the end of the webinar, but please feel free to submit them as we go. Okay, so why should I care about earthwork, especially if I'm not a civil engineer? Well, quite simply, there are many non-civil design decisions which directly impact the amount of earthwork required for a project. And I've listed a few examples of these over to the left. So starting at the top, we have site selection. You know, obviously the existing terrain is a key consideration, but how much is that terrain going to impact project cost and performance? Defining buildable area. Where should we build and where should we avoid? And on what basis do we make that decision? The racking selection, fixed tilt versus standard tracker versus terrain following tracker. And is it worth paying a premium for any of those products? And of course, the structural design of the racking foundations themselves. Do we optimize for the steel? Do we optimize for the earthwork, or can we optimize for both? So it's probably no surprise that these examples, as well as others, can impact earthwork. The challenge is really quantifying the amount of earthwork and being able to do it quickly and accurately. And that's what we want to talk about in today's webinar. Of course, Earthwork is only the first half of the terrain challenge. And as I'm showing on this slide over to the right, the second half is quantifying its impacts on energy yield. That is a complex topic for another day, but it's one that I will touch on again at the end of this webinar. The key point that I want to get across here is that Earthwork changes the terrain. And if I'm using the existing terrain as a basis for a 3D energy modeling effort, then my results are always going to be a little questionable. So in conclusion, understanding Earthwork is central to making informed project decisions. And with that, we're going to start our first of several polls today. The poll should be live at this point. And when is the first time you quantify Earthwork volumes on your projects? Is it during site selection, early development, late development, pre-construction, or in the IFC stages? And I see some results coming in now, which is awesome. We'll give that another few seconds to come in. All right, and I think those results should now be being displayed, and it looks like the majority of folks are expecting to be performing that first Earthwork volume assessment in the early development of the project. Interestingly, there's people who are doing that during site selection, but some people who are also delaying that a little bit. So not completely unexpected results, but interesting. So let's move on. And at this point, I'm going to go ahead and hand it over to Dylan. Dylan is going to take us through some of the more civil engineering heavy topics of today's webinar. Dylan, you want to take it away?
Yeah, thanks, Jason. Hello, everybody. Dylan Mora, civil engineer here at Terabase. Thanks for being here with us today. I'm going to talk a little bit about the fundamentals, some of the elements of terrain following trackers that impact Earthwork. We'll go into some of the challenges that I hope will resonate with all of you, and then I'll hand it back to Jason, who will run a demo of some software we've been working on. So just focusing on the scope. So what are we talking about today? There's a lot of grading that goes on a particular site. You might have substations, equipment pads, roads, and then you have the array grading. But if you look at it from an area perspective, you know, most of the site is within the array. And if you have to do any grading in the array, then it could represent a huge portion of your work. So our purpose today here will center around, you know, defining what a refined approach, what a modern approach would be to earthwork assessments. We need a method that works early in the project schedule, and one that works in the early stages of the project and can be easily rerun as the project transforms. So we're just talking about the arrays today. Next slide, please. All right, go through some terms. I don't want to bore you guys, but they are important. They do impact how much earthwork you have to do. And like Jason said, a lot of times we're deciding some of these things before we even know what the earthwork is. We're working out a solution, and then we're getting an earthwork result without really being able to compare two options. So first term is disturbed area. So we remove topsoil when we do cut and fill. This has an impact on permitting. Disturbed area is the area in which we'll be removing all the top. So we have to remove the topsoil because it is not structurally, it doesn't support loads, and it cannot be compacted. So anywhere where you're putting any cut or fill or any foundations, you have to remove the topsoil. So that's what we are considering as disturbed area. So obviously everyone understands that it's important to minimize this area, but how do you know you're minimizing it? And so that's one thing that we're going to present today. Next slide, please. Talking about units, in terms of volume, I think it's important to understand what units we're talking about. So we want to be clear on that. Soil will change volume as it moves around the site. 1 cubic yard of in situ soil will occupy a little more volume once it is excavated, and a little less volume once it is placed and compacted. The amount by which it swells is called a swell factor, and the amount by which it compacts is called its compaction factors. And these factors are very site specific, and they vary based on the soil types. So it's imperative to include these requests when you're scoping your geotechnical report. You ask the geotech for some recommendations on what they think these might be, because it does have an impact on your cost. You can have swell factors of 1.6. That makes a big difference when you're trying to move that soil around the site. So we want to be clear that our software is estimating bank cubic yards, and we want to highlight that earthwork assessments can be nuanced when you're seeking balanced cut and fill. Next slide, please. Depth of cut and depth of fill. This is missing from a lot of permitting documents. It's an important input for permitting documents, and it's also a very important element for when you scope your geotechnical borings and your pile load tests. So today we aren't accurately estimating these numbers, max cut and max fill, which is making our permit documents less exact, too restrictive, and it's making our geotechnical scopes of work less exact. When we talk about percentage of pre-drilling, say, if we're not boring in the soil that we are that we're going to be working in, like if there's an area of large cut and you've tested that soil, but then you remove that soil, you've tested soil that isn't there anymore. So it's good information to have, and an example of scoping and geotechnical report is that the information you get is only as good as the information you provide in your scope or to the geotechnical engineer. So for example, if you can tell a geotechnical engineer where your structures will be and how much those structures might weigh, the geotechnical report can provide soil properties and foundation recommendations. If you can tell the geotechnical engineer where you're cutting and where you're filling together with those depths, you'll get a better picture of what that means in terms of cost for the project. Deep fill might require under drains, deep cuts might require benching. And so the message I want to drive home here is that geotechnical recommendations have ramifications for project cost. And unless you're telling the geotech where you're cutting and where you're filling and how deep those are, you're missing some potential costs there. Next slide, please. Another basic term, we throw around, terms of piles and piers. For our purposes, they mean the same thing. I'd like to point out that when we say the word pier reveal, we're talking about the portion of steel that's above grade. When we say pier or pile, we mean the entire length. Next slide, please. All right, so this one is one of the more fun ones to talk through. We have a few definitions here. So if you look at the profile that's drawn on the screen there, we have a dashed line that shows what the original grade is. We have a tracker profile drawn in red, and along that tracker we show articulation limits, we show maximum north-south slope, and you can see the torque tube there on the top and the piles supporting that structure. The solid black line is the finished grade, and that finished grade has come from our design of the system. So we've stuck to the articulation limits and the maximum north-south slope. So, and then we've kept our peer reveal window. So the two dashed green lines on the screen that run parallel are what we call the peer reveal window. So that's how much you allow the grade to undulate underneath your tracker. The larger the peer reveal window, the less grading you'll have to do. As you shrink that peer reveal window down to 0, your earthwork volumes are going to increase. The articulation limit also affects the grading. The articulation limit is the maximum allowable change in slope from one bay to the next, so between two pairs of piles. The maximum north-south slope is also affects the earthwork, and that is just the measure of the angle between the horizontal and the torque tube itself. All right, next slide, please. One last fundamental, and hopefully this is something that all of you have thought about before. So we want to talk about topography data. So how are we getting data, and how are we using that in our earthwork assessments? So on the left, you're probably familiar with this type of data. You have what we're calling analog data. You receive points from a surveyor. Surveyor will provide those to you. They'll either provide a surface along with it, or you'll use those points to build a surface to represent your original grade. A surveyor is going to, if you ask for, when you request a survey, you're probably going to specify the contour interval. The survey that you receive back from a licensed surveyor should be accurate to half of whatever the contour interval is. So if it's a 1 foot contour, the surveyor is going to state that it's accurate to 1/2 that, or 6 inches. On the right, there's digital information that's available where each pixel is a data point. Oh, back to the analog. A surveyor is going to provide you with enough data points to ensure that he can be accurate to half that interval. So you might, on a site, they might have, you know, a 50 by 50 grid. It probably won't be a grid. They'll probably take spot elevations where they deem necessary. So you could get, you know, a grid of points that's 50 feet or more apart. Where with digital data, you're getting data that's down, you know, to 1 meter, 5 meter. So when we're talking about analog and digital, it's common for us to maybe dismiss the digital data because it doesn't look the same as our analog data, but digital data can be quite accurate. Next slide. So let's talk about some of the challenges that I also hope resonate with you. We've talked about some terms, and we'll talk about some of the challenges that we face when we're working on earthwork assessments. So, like we've said a couple times already, if you need to assess your earthwork volumes, you need to understand what your peer reveal is, your peer reveal window, your maximum north-south slope, and your maximum articulation. So you pick one value for each of those parameters. And then you'll develop a layout, maybe you already have that. You'll develop a surface model, you'll design the tracker profiles, and then you'll do an earthwork assessment. And if you need to compare two scenarios, you'll need to do that again. And that could take on the order of, let's just say 2 weeks. The tracker profiles are what typically take a lot of the time. The reason that this takes so much time, it's not in step with traditional volume calculations, is because in cases of a substation or a road or some drainage feature, those features have uniform cross sections, and it's quite easy to estimate what the earthwork is for those. Where within the arrays, it's very hard to do that in an easy way. And the only way to really do it, to get accurate numbers, is to design the tracker profiles. And some of your sites are going to have hundreds and hundreds, if not thousands, of tracker profiles. And so you'll have to design all those profiles. That's what takes so much time. So we'd like to shrink that amount of time to get it more in line with how we estimate other earthwork for other elements of the site. Next, please. So it'd be nice, it was nice to see that some of you were doing earthwork assessments very early in the project, because that's when you can have the most impact on the project. If you look at the graph there, you have project schedule on the bottom, and you have low to high influence on the project on the left, on the vertical axis. So the earlier you do these earthwork assessments, the earlier you can make decisions using earthwork. A lot of times we're making decisions in 2D when we should be really making them in 3D. And we feel that earthwork is a blind spot in early stage development, certainly for prospecting, certainly for development. And then engineers are not able to iterate because it takes so much time to weigh different scenarios. Next slide, please. Our second challenge, our first challenge would be, limited data. So we may not have a layout, may not have topo. Our second challenge is time and tools. These kind of go hand in hand, but even if a layout does exist and a topo is available for the site, the second challenge is not having the time or the tools to develop an earthwork assessment. These take significant time, and they also take expertise. They take time because our tools haven't caught up with our needs yet. Analysis is typically done in a CAD environment that has certain input requirements and requires certain skills to operate. And then you need someone to interpret the results. So early in the stage, civil designers, civil engineers have not yet been engaged, and so that's our second challenge. Next slide, please. All right, so hopefully we can get this playing, this video. So challenge number 3, this is the most fun. The design of terrain following trackers is exacerbated by the number of parameters available in terrain following architecture. We have too many variables to play with, and it makes it very hard to design. The video you see on the screen helps to demonstrate the challenge. We have a dark brown line representing the original grade. Dark blue line represents what a standard tracker profile might be. And the 2 light blue lines represent what our real challenge of the terrain following design is, and that's iteration. So you start to lay out the tracker using the parameters that you've decided on, and then you iterate, and you do that over and over and over, but you don't know if you're really optimizing the site or optimizing the earthwork. So let's see. Yeah, so you see the light blue line that's laying out our tracker, and then you see it morph down over the site, and then we have our yellow line that's adjusting, that shows what the finished grade will be. And this is just one row, so you have hundreds of these, thousands of these, and it really turns into a sort of Tyrannosaurus Rex, if you will. It's very tedious, and you don't really know if you're optimizing things. Next slide. So what is our state of the art? Right now, we're creating exclusion areas based on slope. We're filling the site for maximum capacity, and then we're using our manual or custom tools to design tracker profiles and earthwork volumes. And we're doing all this in 2D. And so we really feel that earthwork needs to be pushed up in the schedule. It needs to be done early and often, and we need to be able to compare different scenarios. So with that, I'll hand it back to you, Jason. Thank you.
Great, thanks, Dylan. And now let's head into our second poll. This is should be live at this point, and this is the first part of a 2-part question. So what software tools do you use to perform earthwork assessments? And I'm seeing some responses come in. It's great. Let's give it a minute. All right, so we should be displaying the poll results at this point. About half of the attendees are using Civil 3D or expect the earthwork assessment to be done within Civil 3D. A large number of others are using PVCase or some type of custom tool or other software. So that's good feedback. Let's head into our next poll. Which should be live at this point. And it's a second part of a two-part question. How satisfied are you with your preferred software for running earthwork analysis? And we'll give that a minute as well. All right, so we should be displaying the poll results at this point. It looks like it's somewhat of a normal distribution where we've got most people neutral. We've got some folks who are satisfied, some folks who are dissatisfied, but not too many people who are either extremely satisfied or dissatisfied. Thanks for participating in those polls. Let's keep going. All right. So at this point, I want to start to talk about a modern approach to earthwork assessments and really Terrabase's modern approach to earthwork assessments. And you know, the way that we want to address many of the challenges that Dylan discussed is really to, no surprise, leverage software to really help enable closing of that design iteration loop so that we can make more informed decisions earlier in the project lifecycle by incorporating some pretty dependable earthwork assessment information. But this is really only possible with extremely fast and accurate earthwork analysis. We need to be able to do this in seconds and minutes rather than days or weeks in order to iterate over a lot of different scenarios. So if we're just sort of taking a straight line path, from some of the early design decisions through to design, only considering a couple of different earthwork scenarios may be okay with existing tools. But if we want to test a lot of different variables, we really need to be able to iterate quickly. So today we're introducing Terrain Pro as our solution to closing the loop on the earthwork challenge and allowing for that iteration over many different earthwork scenarios much earlier in the project lifecycle. You may have noticed also over to the right-hand side the PlantPredict 3D logo. So yes, we will be releasing a new 3D capable version of PlantPredict, and I do have more information on that later towards the end of this webinar. But specific to earthwork, Terrabase has been on a journey over the past year and a half to create software that can effectively close this loop. In early 2022, Terrabase began developing an algorithm. We called it Mercator internally to optimize earthwork across different racking configurations and the variables that Dylan was discussing earlier in the presentation. By late 2022, Mercator had been fully developed and packaged into a cloud-based API. And over the last year, Terrabase has provided Mercator-based earthwork assessments to developers, EPCs, and tracker suppliers on over 120 projects globally. That's over 30 gigawatts of projects through our software-enabled consulting services. And now in Q4 of 2023, we're going to be releasing that Mercator algorithm. It's going to be accessible through our Terrain Pro application, and that is going to be part of the PlantPredict suite of software tools. And so now I would like to step into a preview of Terrain Pro. So let's hop out of the presentation deck and let's hop into Design Pro and Terrain Pro. So you should be at this point seeing our Design Pro software, and this is where I want to start. And I want to be able to show two different workflow scenarios. The first is that I want to show in the land prospecting stage, when I'm looking at two different sites, how can I get a sense of the relative earthwork that's required between those two different sites? So that's kind of the first workflow that I want to show. And then once I've picked a site, how can I iterate quickly over different tracker scenarios? So for example, a standard non-terrain following tracker versus a terrain following tracker. How can I quickly quantify the relative earthwork between those two different scenarios? So I'm going to show kind of both of those workflows pretty quickly here. I think we're doing pretty good on time. So let's get into it. So Design Pro allows us to define a site and run simulations, which effectively are automating layouts, running energy models, taking material takeoffs, doing cost estimates, economic estimates, and now pulling in earthwork quantities. So we're going to be pulling in earthwork data from our Terrain Pro application. And similar to how when we run a simulation in Design Pro, that's being handed off to PlantPredict to run the energy simulation. Well, going forward, earthwork simulations are now going to be performed by Terrain Pro, and that sort of earthwork numbers are going to come back into Design Pro to inform our cost estimate and our economic models. So right now what I've done is I've defined a north site and I've defined a south site. And both of these sites are almost identical in terms of overall area. They both have some exclusion areas associated with them. And so from a bird's eye view, they seem pretty similar. So what I've gone ahead and done prior to the webinar is I've run two simulations, one on each site. And I've run the simulations with the same system capacities, both DC capacity and AC capacity. This is about a 27 megawatt system. I've used basically the same GCR, about a 0.3 GCR. I have the same module, the same central inverter, and the same racking system. This is a 3-string 87 module standard tracker is what we're currently modeling. And so you can see both of the sites I've run similar analysis, and I have my results down at the bottom, and I can look at the individual trackers just to show that those are individually modeled. So we have combinations of 3-string trackers and 2-string trackers on this site. But what I want to call attention to is in the results pane, you can now see that there is a total grading quantity. And in the north site, we're currently at 100,000 bank cubic meters. And when I flash over to the south site, you'll notice that that same quantity is actually 550,000 bank cubic meters. So there's a huge difference, a nearly 5x difference in those earthwork quantities. And so if I take a quick look at going back to my site plans, and I kind of look at these sites from a 3-dimensional perspective, I can definitely start to see that my south site has much more terrain than my north site does. And so that's coming through in our earthwork quantities estimate. So how do we get to those earthwork numbers? That's what I want to show within Terrain Pro, because that's really the exciting part. So like I said, when I run a simulation in Design Pro now, it's handed off to Terrain Pro to do the earthwork analysis. And the core sort of earthwork quantities are pulled back into Design Pro to inform the financial models. But I can step off into Terrain Pro, and let's do that now, and take a look at the earthwork in detail. And so Terrain Pro is a separate application. It speaks to Design Pro, but it's its own application where I can just study the earthwork. And when I first pull up Terrain Pro, what I see is the south side again, and this is showing a heat map of the earthwork that is expected to be done on this site. The colors represent cut and fill. The red is 6.3 meters of fill. The purple is as low as 10 meters of cut. And I can also visualize this data differently. So I can look at the original surface, for example. I see that geographic feature in the southwest that I saw in Design Pro just a minute ago. I can look at how the finished surface is affected. I can look at the piles. I can look at where my cut fill is expected to happen, just more from a binary perspective. So red being cut, blue being fill. And over to the right, just to sort of orient everybody with the interface, over to the right, I have my quantities. So I have my total earthwork volume. This is the 551,000 bank cubic meters that we saw in Design Pro. So this is the value that was pulled into Design Pro. But I've broken these out, or these are broken out by cut and fill. I have the total disturbed area by cut and fill, and the max depth of cut and fill. I can also view each tracker on the site and view the profile of that tracker and the associated, get a sense of the associated cut or fill for that tracker. So in this particular case, this is tracker number 1. We can look at any tracker, we can select it on the map as well, and we get a sense that there's some fill that needs to happen in order for the tracker to meet its design constraints. Over to the left, I have where I can define my earthwork configurations. So these are really the design constraints that I've specified in Design Pro and have been pulled into Terrain Pro. So within Design Pro, I had specified a minimum pile reveal of 1.5 meters, a maximum torque tube axis slope of 15 degrees, a reveal window of 300 millimeters, and I said this was a standard tracker, so it has a maximum slope change of 0 degrees. So that defines our configuration 1, which is what we were brought to view. But the power of this is being able to look at other earthwork scenarios as well. So let's go back to our earthwork heat map, and let's take a look at what happens if I were to consider an articulating tracker. So I'm going to specify that I can allow up to a 1 degree articulation angle. Oh, that looks like it didn't catch. I didn't hit the check mark. There we go. Okay. Okay, so now what I've effectively done is I've created a new configuration. This is configuration 2. It hasn't been run yet, but configuration 2 is the same as configuration 1, except that I'm allowing for a 1 degree articulation angle. So let's go ahead and run that. And what it's doing is it's analyzing and optimizing the earthwork for that new configuration. And this is, one of the exciting things is just how fast this is. This is literally, probably less than a minute. It's going to be able to do 27 megawatts worth of earthwork analysis. So you can see visually from the heat map that the earthwork has gone down substantially. If I look at my total earthwork volume, I'm now at 220,000 bank cubic meters as opposed to 550,000 bank cubic meters. That is over a 50% reduction in earthwork just by allowing for that articulation angle of 1 degree at the tracker. And when I look at that same tracker profile, I can now see for that tracker number 1, I can now see that I don't need any earthwork. The terrain or the tracker requirements can be satisfied just by making articulation changes at each pile. I can also, just as another sort of visualization, I can also get to, I can also take a look at any pile that I would like to look at, or any tracker that I would like to look at, any tracker profile that I would like to look at on the site. So in this case, there's quite a bit of cut that's required, even with the articulating tracker. But I think you can see kind of the power of the software, and at least based on this very brief demo, obviously you can change many of these other parameters to affect the results. And there's a number of downloads that we can get out of this to make better decisions. I'll be touching on that briefly, but I also want to say that we will be giving a much more detailed webinar just on Terrain Pro in the future. And this was just meant to serve as an initial kind of preview. So let's hop back into our presentation. All right. And let's go to our final poll question, which is, during development, how much are you paying for earthwork assessment per project? Consider a 100 megawatt project. And we'll give it another few seconds here. All right. So the poll is closed. We should be displaying the results at this point. It looks like the people, nearly 40%, are paying under $10,000 in the early stages of development. But there is a bit of a distribution where people are paying a bit more. All right, well, thank you for that. Let's move on. Okay, so we're gonna get into kind of the closing portion of our webinar today. And some key takeaways. So where does earthwork assessment fit in? And we want to start to think about earthwork assessment similar to running an energy model. So we believe that running earthwork models should occur at every stage of the project from site selection onward. Obviously the input data into those earthwork models may be more limited in the earlier stages, but we still believe that doing that can help inform other project decisions and avoid surprises down the road. In the example that we went through, we were able to very quickly compare two adjacent project sites with vastly different earthwork requirements. Now, granted, this was kind of an extreme example, but I think most people would sense that there was going to be some pretty big differences in earthwork, but being able to quantify that very quickly is pretty powerful. So hopefully that point came across. We also wanted to mention that there is some useful information about piles that can also be obtained from Terrain Pro. I didn't show this during the demo, but pile data can be downloaded in CSV format showing the pile coordinates for every pile, the existing and finished grade elevations at each pile, and the pile reveal and top of pile measurements for every pile. The pile reveal height for every pile and the ability to iterate over different pile reveal windows can provide visibility to the structural engineer and allow for steel optimization. As an FYI, we have found that pile reveal window and tracker type can impact total steel pile costs by more than 10%. So being able to iterate over this can be helpful from that perspective as well. Wrapping up the Terrain Pro discussion, we expect this to be released after RA Plus in Q4 of 2023. We're planning to first release this to our PlantPredict enterprise customers as kind of a pre-release. Please stop by our booth at RA Plus for hands-on demo and watch out for an upcoming webinar where we're going to go into much more detail on how to use Terrain Pro, the data that we can extract from it, and the integrations with other PlantPredict products. Finally, we do want to reiterate that although Terrain Pro is a brand new product, the underlying algorithm has gone through significant validation on a wide variety of real-world products. So we feel quite confident in the underlying logic behind it and are excited to be making this available to more people. Impact on energy. So I mentioned PlantPredict 3D in a previous slide. We're also excited to tease in this webinar the upcoming release of PlantPredict 3D, which will include a 3D shade modeling within PlantPredict Energy Model. It'll still be a cloud-based architecture, of course. Integration with Terrain Pro for accurate mounting system configurations, sub-hourly time series, bay-level shading factors, the ability to import PVC files, an advanced tracking algorithm library, and custom tracking angle time series inputs. So we've been hard at work on PlantPredict 3D for most of 2023, and we plan to begin launching PlantPredict 3D in late Q4 of this year. We believe Terrain Pro puts us in a position to more accurately define mounting structure geometry, which is essential for 3D shade analysis and energy modeling. And this brings us to our last slide today. I'd like to invite those who will be at RA Plus to come stop by our booth, 7021. We'll be giving hands-on demos of Terrain Pro and our other PlantPredict products. We're happy to talk to you about PlantPredict 3D and give you some more information about what that's going to do. We're happy to talk to you about using our Mercator algorithm either through Terrain Pro or through our consulting services. I'll be there, Dylan will be there. We'll have a number of our team members there who will be happy to hear about your projects, your challenges, your needs, and just in general, interact with the large-scale solar community. So yeah, please stop by. And with that, I think we'll start our Q&A. So I've got another team member who's helping me on the Q&A front. Let me see if I can pull that up. Give me just a sec. All right. So first question is, what is the topo source that Terrain Pro is using? And can I use my own topo data if I have it? I can take that. Dylan, do you want to take that one maybe?
Yeah, certainly. Yeah, no, that's fine. Yeah, so we, for Terrain Pro, we've integrated over 70 sources of national regional terrain data, so covering almost the entire globe. The quality of that data really depends on where your project is. But in most cases, we have several options to choose from, and we include the details of that source of data. So the name of the data set, when it was published, and its resolution. And you can run scenarios using different sources to just compare. We will get into more details about what those sources are. And you can also find it in our user guide online. The first release of Terrain Pro will only pull in terrain data we've sourced and made available. You will not be able to upload your own, but this is a feature that will be coming in 2024.
Yeah, thanks, Dylan. And just to clarify, our Mercator algorithm and the consulting services that we provide, we are able to upload our own terrain data, but you're right, the Terrain Pro product, which is going to be the first iteration of that product that's going to be released, is not going to allow that custom upload data, at least not initially, but that will be coming soon after. Okay, second question. Can I upload my own CAD layout to Terrain Pro? Dylan, do you want to take that one again as well?
Sure, yeah. So, similar to the topo, Terrain Pro is only pulling layouts from Design Pro. So you do a quick layout in Design Pro, you pull that over in Terrain Pro. This enables, it's fast, and it allows the two to connect, and it brings in quantities for your LCOE calculations. But we are working on CAD integration for the near future, and as we mentioned earlier, we have used our Mercator titled algorithm in our consulting practice to perform earthwork assessments on over 100 projects. And in those cases, we've performed the analysis based off of CAD layouts. We've done quite a bit of work consulting on that front, but that is not externally facing yet. But we do have an API integration available for our enterprise customers. So come please talk to us at RE Plus if you're interested.
Great, thanks, Dylan. Okay, third question, how much does it cost? I assume that means how much does Terrain Pro cost? I can take that one. So the good news is that Terrain Pro is going to be included in the PlantPredict Pro subscription level. So the Pro and Enterprise subscription levels will sort of automatically get the Terrain Pro application or access to that. Terrain Pro currently starts at $6,000 per year. And again, that is a suite of applications that not only includes PlantPredict, the energy model, but also Design Pro, Voltage Pro, and soon to be coming Terrain Pro. Note that we will be announcing our 2024 pricing updates pretty soon here. So, but as of today, it's $6,000 per year starting point. So, okay, moving on. What does it mean to design tracker profiles as step 3 of today's earthwork assessment? So I think Dylan, that's in your court as well.
Sure. So tracker profiles for standard trackers are relatively straightforward. Don't have many parameters to play with there, but tracker profiles for terrain following trackers are much more complex because we're following the terrain, within the limits of the parameters, such as maximum articulation at the joints, maximum north-south slope along the torque tube, peer reveal window, so how much you're allowing the grade to undulate or change underneath the profile, and then your peer reveal. The purpose of the terrain following tracker is obviously to minimize earthwork, but terrain following trackers do have limits, and articulation angle is one of those parameters that dictates how closely a tracker can follow the terrain. And so to optimize or minimize earthwork, a designer must iterate many times, and that lends itself very well to a software solution. And our software iterates automatically to optimize and optimize the profile and minimize earthwork. It's quite easy to design the profile by, quote, laying the tracker on the ground and then looking for areas where the articulation exceeds the maximum. But we don't feel like that's the best solution because that's too manual. We don't want to go row by row and make decisions about, does this exceed the articulation limit and should be grayed here, or just delete the row. So our profile optimization allows the user to make judgments on the profile and associated earthwork, and it does that automatically. So optimization is the goal here.
Great, thanks, Dylan. All right, we've got about 2 minutes left before the top of the hour. Why don't we go ahead and try to take 2 more questions? So the next question is, how do you consider east-west slopes and constructability an item that most conveniently neglect? Dylan, do you want to take that one as well?
Yeah, definitely. Yeah, so with constructability, I think you're referring to the maximum slope that is practical to build on, which can sometimes be lower than the maximum from a tracker parameters perspective. Terrain Pro allows you to model different maximum torque tube axis slopes and solve for the resulting earthwork. East-west slope is currently not one of our design parameters, but this can be modeled with the results that come out of Terrain Pro. You can get finished grade elevations, top of pile elevations, and then you can model those to visualize the east-west slopes. In my humble experience, I've found that east-west slopes, they're typically, if they're too steep for the tracker, they're too steep to even build on. So that's my experience. But yes, you can model that with the data get out of the Terrain Pro.
Awesome, thanks. All right, let's do one more. We'll do one more for the formal conclusion, and then maybe we can, if people want to stick around, we can answer a few more. So next question, does the output include an export for proposed contours? I'll take that one. So the answer is yes. The output that can be downloaded in a CSV format includes the finished grade elevations at each pile, which you can import into software like Civil 3D to create a finished graded surface and generate contour lines from. So yes, it is possible to use the output of Terrain Pro into a CAD-based environment, to import that into a CAD-based environment to understand both original grade and finished grade. Okay, we're at time. Why don't we go ahead and take one more question? When you say Terrain Pro is optimizing for earthwork, is it also taking into account steel cost and pile sizes? That's a really good question. I'm gonna go ahead and try to answer that, Dylan. If you want to maybe supplement what I said, feel free.
Sure.
So optimizing earthwork for Terrain Pro, what we mean is essentially minimizing the earthwork for that particular configuration. You can solve for the foundation design and steel quantities from the results of that. If you do this across several iterations or several different scenarios, you are able to understand the larger optimization perspective that includes the steel, let's say the reveal window, or the pile height. And so you are able to get that information. Terrain Pro doesn't automatically optimize for steel. And it's important to also state that it's not doing structural analysis, right? So we're looking at the pile of grade, and using that, using the constraints associated with the pile limits above grade, to define or to optimize earthwork. I don't know if you want to supplement that, Dylan.
Yeah, I'll just say, like you said, it doesn't do it automatically, but as Jason demonstrated, this is a very quick analysis. It's a very accurate analysis, and you're able to look at different scenarios, and that's what I think one of the main messages from our whole time here, whole hour here, is that we should be looking at alternatives. We should be comparing, do I want to do more earthwork and use less steel, or do I want to use more steel and do less earthwork? Those are all decisions that we should have the ability to make, and it's my belief that we're not making those today. Depending where you're at on the globe, sometimes steel is cheaper, sometimes earthwork is more expensive, you don't know. So it's good to be able to weigh these different scenarios, and you can do this in a matter of minutes instead of weeks. And I think that's what's most important here.
Great. Okay, I'm gonna. We're on a roll here. Let's do one more. I lied that was the end. Let's do one more. Does Terrain Pro use cloud computing or hardware computing for optimizations? So it's done in the cloud. Really, all of the PlantPredict suite of software do not depend on your local hardware. These are all done in the cloud. This is one of the great things about cloud-based systems, is that we can spin up additional servers and we can run things in parallel. So for example, in the Design Pro simulation, the energy model may be running on one server while the terrain model, earthwork model, may be running on a separate server, and being able to do that in parallel and also not tie up your own hard drive is great. So, okay, we're about 5 minutes over, and this has been, I think, a really great webinar, and we've appreciated presenting. Thanks so much for joining. For the remaining questions that we've received, we'll try to answer those and respond via email, and get back to you within the next couple of days. So anyway, I think Dylan and I will sign off at this point and close the webinar. Thanks again for joining.